Lesson 10, the Week 1 Capstone. No new theory here. You already own the whole toolkit. Axial, shear, torsion, bending, deflection, transformation, combined loading, and strain energy. This lesson is about using it under exam pressure, recognizing the load type in seconds, reaching for the right formula, plugging in one clean unit system, and checking before you commit. We'll rip through 4 fast problems that span the week, then lock in the lookup discipline, the unit checklist, the time budget, and every trap we've flagged. The method first. Every problem this week fit one 4-beat loop, and so will every problem on the exam. 1. Recognize the load type: axial, torsion, bending, transverse shear, or a transformed stress state. 2. Pick the formula. There's essentially one per load type, so recognition forces the equation. 3. Plug into a single unit system. 4. Check the units, the magnitude, and that you took the right shear about the right axis. Name the loading, and the rest is mechanical. Watch it run 4 times. Problem 1. Axial. Recognize a bar under axial pull. Stress is load over area, and stretch is P times L over A times E. Convert to newtons and millimeters up front, and the stress lands straight in megapascals, the stretch in millimeters. 202. 1 recognition, 2 answers. Problem 2. Torsion. Recognize a shaft carrying torque. The surface shear is Tc over J, which for a solid round collapses to 16T over pi d cubed. The maximum sits at the outer fiber and falls to 0 on the axis. Keep the torque and diameter in one unit system before you divide. Problem 3. Bending. Recognize a beam. First, the maximum moment. A central point load gives PL over 4. Then the peak fiber stress is MC over I. 2 things to guard. The moment of inertia is taken about the neutral axis, and C is the distance to the farthest fiber. Problem 4. Plane stress. The transformation problems from Mohr and combined loading. The principal stresses are the average plus or minus the radius. Now the trap the exam loves: maximum shear. In plane, it's simply the radius. But when both in-plane principles share a sign, the out-of-plane stress, 0 for plane stress, becomes the true minimum, and the absolute maximum shear, largest principle minus that 0 over 2, exceeds the in-plane value. Always bring in the 0 out-of-plane stress before you name the maximum shear. Under time pressure, lookup discipline decides whether you finish. Know the core formulas cold: axial, torsion, bending, transverse shear, transformation. So the handbook is a confirmation, not a search. Reserve lookups for the things worth looking up: section properties for a shape, and material constants like the modulus and yield strength. Navigate by neighborhood. Stress and transformation cluster near section 2.10, torsion and beams near 2.11. Confirm, grab the number, move on. The unit checklist. This is where points leak silently. Newtons and millimeters give stress in megapascals, so don't leave loads in kilonewtons. Keep the moment of inertia and the polar moment in millimeters to the 4th, paired with distances in millimeters. The angle of twist comes out in radians. Convert to degrees only at the very end. Bring a kilonewton meter moment down to newton millimeters before dividing. Pick one unit system per problem, and write it down before you plug anything in. Time budget. And it's qualitative on purpose. 80 questions across a long day means only a few minutes each on average. First pass, solve what you recognize quickly and commit. The moment you're stuck on what kind of problem it is or lost mid-lookup, flag it and move on. Don't let one problem eat the time 4 easy ones needed. Come back on a second pass. And since there's no penalty for guessing, never leave a blank. Now the review everything slide. Every trap from the week in one place. Shear and torsion. Single versus double shear changes the load per plane. The polar moment of a hollow shaft subtracts 4th powers, not radii, and the angle of twist is in radians. Bending. Take the inertia about the neutral axis and C to the farthest fiber. Transformation. More angles are double the physical angle. Superpose stresses before you transform. And remember, the absolute maximum shear brings in the out-of-plane 0. Energy. Resilience is the area to yield. Toughness, the total area to fracture. Not the same thing. The Week 1 recap on one screen. 5 formulas: axial stress and stretch, torsional shear and twist, bending stress, transverse shear, and the transformation to principal stresses and in-plane maximum shear. And 5 checks that catch most mistakes. 1 unit system: radians for the twist, the right axis for the inertia, superpose before you transform, and in-plane versus absolute shear. You can build a stress state, read its extremes, and account for the energy it stores. That's a wrap on Week 1, Mechanics of Materials 1. 10 lessons: axial and shear, torsion, bending, transverse shear, deflection, Mohr's circle, combined loading, strain energy, and this capstone, stitching them together under time. More machine design and materials weeks are on the way. Subscribe so the next one reaches you. Everything's at peprepengine.com. A cheat sheet, worked solutions, and a short quiz are attached here. If the course helped, please subscribe, and good luck on exam day.